The first derivative can be used to find local minimum and maximum points in functions. Using the first derivative test, we can find a couple of different things that are interesting about functions. Let's do some quick math calculus first. So we've got a function y equals x squared minus x. In order to take the first derivative, all we have to do is use the power rule here. And so if we say f primed of x, we're going to get 2x. And then our coefficient is 1 here, so we'll just take away the power of 1, change it to a constant of 1. F primed of x is equal to 2x minus 1. We're going to set that equal to 0. We get 2x minus 1 equals 0. And this is easily solved. We get x equals 1/2. Right? So we know this is a point where it's either a local minimum or a maximum, and this is the only one. Sometimes there are more than one critical point there. We don't know right now if it's a minimum or a maximum. So what we have to do is go back to the original equation, and we're going to pick a point to the left and to the right of 1/2. So I picked f equals 0. If we want to substitute 0 for x in the original equation, we get 0 squared, which is 0. 0 minus 0 is 0. And then let's take a point to the right of 1/2. I've chosen 1. And so we get 1 squared minus 1, which is 0. And so both of these are less than, I'm sorry, I'll do one more here. And then we'll take that critical point there, f of 1/2, and we get 1/2 squared, which is 1/4. 1/4 minus 1/2. Quarter minus 1/2 is negative 1/4. And so we see 1/4 is less than both of these points. And that means that our function has, so here would be f of 0, and then over here would be f of 1, and then here would be f of 1/2. So we have a minimum here. Minimum at x equals 1/2. So another example. Again, just using the power function, or sorry, the power rule. We're going to drop down these exponents, multiply by the coefficients, so we get f primed of x is equal to 3x squared minus 18x plus 24. Continue on. We can divide by 3 here, and we get x squared minus 6x plus 8. And so we can easily factor this. We've got x and x. We see a plus sign here, but a minus sign here, so we need to have two negatives. And we've got 4 and 2. So we've got two different critical points. We've got x minus 4 equals 0 and x minus 2 equals 0. Therefore, we can solve easily. X equals 2 and 4. But again, we don't know if they are minimums or maximums, right? One's probably going to be a minimum, the other going to be a maximum. If the slope is 0 twice over a function, obviously we must have one minimum and one maximum. So let's take a point to the left of x equals 2. We get f of 1 is 1 minus 9 plus 24, or 16. And then we'll take f of 2. Here's our critical point. And we get 8 minus 36 plus 48. That's equal to 20. And then f of 3, just keep moving to the right. So we've got a point to the left of our critical point and a point to the right of our critical point. F of 3 is equal to 27 minus 81 plus 72, or 18. And so we see 16 and 18 are less than 20. That means we must have a maximum at f equals 2. Let's keep on moving. We'll do our other critical point, f of 4 here. And we get f of 4 is 4 cubed minus 9 times 4 squared plus 24 times 4, or 16. And then finally f of 5, and that is equal to 20. Right, so we've got our other critical point here. Right, it's less than this one. Both the point to the left and point to the right of f of 4 are greater than f of 4. And so here we've got a maximum, and then a minimum. All right. Let's take a look at another example. Sine squared of x, we've done this derivative before. Remember, this is a compound function. It's the same as sine of x, the function sine of x squared. So in order to take the derivative, we have to use the chain rule. F primed of x is equal to 2 sine x times cosine x. Remember, you have to take the derivative of the inner function and multiply that by the derivative of the outer function. We're going to set this equal to 0, same as we did before. And so this is true. This is true when either sine of x or cosine of x equals 0. And you should know already that sine of x is equal to 0 at the origin. So we've got when x equals n times pi. So 0 pi or 0 at 1 pi, at 2 pi, etc. And then cosine of x is equal to 0 when x equals pi over 2 plus n times pi. Right? This is very important you have that n because these functions go on forever. Right? And so at pi over 2, you know, cosine equals 0, it starts up at 1, then moves down to 0 at pi over 2. So when either of these conditions are true, then we're going to have our local minima and maxima. And so let's start plugging in some values here. I'll change a different color. All right, let's try f of 5 pi over 6. Right, that is to the left of n pi, right? So we're just 1/6 pi to the left of pi. F of pi over 5 pi over 6 is equal to sine squared times 5 pi, sine squared, excuse me, of 5 pi over 6, and that's equal to 1/4. And then we know that f of pi, or n pi, is equal to 0. Continue on, we'll move to the right of pi, we just go 1/6. It's just an easy number. F of 7 pi over 6 is equal to 1/4. And so we see that f of pi is a local minima. Right, so n pi is a minimum. Change to a different color here. All right, let's take a look at the other one. We'll start out at f of 5 pi over 4, right? That is just to the left of, sorry, it's just to the left of 3 pi over 2. Continue moving to the right. And so f of 5 pi over 4 is equal to 1/2. F of 3 pi over 2. Don't get confused that I didn't start at pi over 2. I was just continuing off to the right since we ended up here at 7 pi over 6. 5 pi over 4 is to the left of this point, and this is supposed to be where cosine is equal to 0. So we've got pi over 2 plus n, which is 1 here. Pi over 2 plus 1 pi is 3 pi over 2, and that's equal to 1. Okay, and then let's try f of 7 pi over 4 is equal to 1/2. Right, so we see that this point is above both of these, therefore pi over 2 plus n pi is a maximum. Okay, remember again that when we take the derivative of a function, we're getting the slope of a function at a certain point. In order to find local minima and maxima in any sort of parabolic or sine or any other quadratic formula or equation, we know that minimas and maximas have slopes of 0. So we're looking for those 0 points in the first derivative, and then we're going to take points to the left and to the right of those critical points. We're going to plug them in and see if our values for the critical point are less than or greater than points to the left and right. If the critical point value is less than points to the left and right, then it's a minima. If the critical point value is greater than points to the left and to the right, then it's a maxima.